Swayam Prabha. Digital India. Educated India.
So, in this lecture we are going to look at the interface between public and science. So, how do members of public interact with science, and what is the, in what kind of situations the engagement becomes more deeper and intensive and more deeper and intense. We will see in some instances how this kind of engagement becomes more deeper and intense. See, in our country, several organizations were involved in popularizing science to inculcate scientific temper among people to look at the world around them. Scientific outlook would contribute to change in the consciousness of people about nature and about themselves. The model that was used was a positivist model, according to which science has a definitive knowledge about the world and people have to accept the knowledge without asking critical questions. That was the first phase of popularizing science. Several organizations were involved in the early 60s and 70s. So, they tried to convey what science tells about the world, what science tells about the various resources and so on. I think people were asked to sort of accept what was being said by communicators of science. Then the model that was used in science communication was public understanding of science, and this model focused on enhancing scientific literacy among people, their attitude towards scientific research. The idea was to find out what are the perceptions of people about science and whether these perceptions are in conformity with the kind of knowledge that exists in the scientific world, and if the knowledge was not in conformity with, if their perception was not in conformity with what science claims, these perceptions were changed by various means. Various strategies of communicating science were used in India. Organizations like KSSP, Kerala Shastra Sahitya Parishad, produced books, periodicals in regional language and organized science exhibitions, and there are several organizations in India which have done this in different parts of the country. And there is one huge Jana Vigyan Jata that was carried out in the country in the late 80s. All India People Science Movement and All India People Science Network are also organizations which are involved in trying to communicate science to people. Public engagement with science is the later stage where people do not uncritically accept science and scientific knowledge. Developments in modern biology and genetic engineering technologies and accidents at the atomic energy plants have made people ask questions about the certitude of science and fail-safe technology. For example, the accident that occurred in Fukushima in Japan really made people think about how this kind of accidents can occur in spite of the fact that there is certain kind of due care that was taken in building these plants. Similarly, Chernobyl disaster, which really released lot of radiation, and the radiation travelled all the way to northern Europe. So, these kind of incidents created lot of awareness among people to see, to question, to challenge science about its claims on issues like safety and issues like human health. Public could see the nature of technologies and risks associated with technologies and control over technologies and actively participating in the debates over technology. So, today's context, science and technology have become interpenetrating systems of knowledge or technoscience, and S&T, science and technology, are used as means for achieving sustainable development or inclusive development. And in this case, we should really remember that development is a value-loaded concept. It has a direction, it has a content and means to achieve development goals. Direction means in which direction we should take our society, what is the desirable direction in which we should move, and then what is the content that can take us along this path. Content meaning certain kind of programs in agriculture, industrial growth, and so on. And in all this, the means used were science and technology. So we have these three kinds of science one can see. One is state-driven science, market-driven science, and public-driven science. In the state-driven science, we have a lot of R&D organizations in our country. In India, research council like ICR is concerned with agricultural issues, agricultural productivity. ICMR is concerned, Indian Council for Medical Research is concerned with health issues, nutrition issues, and so on. CSR, Council for Scientific and Industrial Research, is concerned with promoting industrial technologies, industrial development. And ICSSR, ICPR, ICSSR, Indian Council of Social Science Research, and ICPR, Indian Council for Philosophical Research. ICHR is Indian Council for Historical Research. These are some of the councils that we have. And especially after India became independent, Jawaharlal Nehru, under his leadership, Jawaharlal Nehru said the future belongs to those who make friendship with science, and he said science can really take our country forward in achieving rapid economic development after the devastating colonial rule. So this policy was announced in 1958, which recognized the importance of science and technology in achieving cultural transformation and economic transformation of the country. Then we have this technology policy statement in 1983, which also talked about improving technologies, and also talked of the idea that there should be mass production and also production by masses. Then 2000 policy, science and technology policy 2000 integrated both science and technology. They saw that they cannot be separated, and 2013 policy, science, technology and innovation policy, really wanted to encourage science and technology to produce innovations, encourage organizations to produce innovations, because in the context of WTO provisions on IPRs, we must produce novelties. And earlier in 1950s and 60s, what we did was we imported technologies, and later we resorted to import substitution, and we also tried to produce indigenous technologies. Market-driven research as IP and consequences, especially private sector research, R&D, one can see that research and development in today's context is getting concentrated in corporate sector, private corporate sector. Knowledge production for patents or products and processes is the emphasis of this kind of R&D. To establish monopolistic control over the products, novel products and processes. And of course, this monopolistic control has consequences for access to technology, and because the products could be the price of products could be high, and then the companies also resort to planned obsolescence, in the sense that they make a product obsolete after a few years. So then again you have to go back and buy a new product. For example, this happens all the time in automobile sector. After 2 or 3 years, the models of the cars are replaced by new models, and old models you will not get spare parts, and you have to sort of either buy new one or give up the cars. So this obsolescence is deliberately brought into the industrial production by the private corporations, and there are issues like safety for human beings and environment, and now people are talking about public private partnership, and this public-private partnership is supposed to provide some synergy between public sector and private sector for achieving results, but actually this kind of collaboration has to be done on mutually agreed terms and credit sharing, regarding credit sharing, regarding revenue sharing and so on. And this is very important to incorporate this in the memorandum of agreement that is entered into between private sector organizations and public sector organizations. We have to regulate regulation to minimize risk to human beings and environment. The product that is produced should be safe for human beings and environment. And we have really started some ventures in public-private partnership. But I would like to mention here, we also should have a public-public partnership. In India, public institutions built up enormous infrastructure over the years and human resources. They work in silos. It means they do not interact with each other. No significant collaboration among them one observes. So there is a need to bring them together to produce new products, processes, and there is a need to exhaust this potential of this partnership, public-public partnership, before canvassing for public-private partnership. So we will have to pay special attention to bring all the public sector and R&D establishments, the universities, industries, and so on. They should be asked to industry, research laboratories. They should come together to produce novel products and novel processes. Then there is this society-driven science, which is based on the demand of people. People demand certain kinds of solutions for problems, and that also has to be taken into account by the R&D organizations. And so farmers can say that they can always propose, they can always articulate the problems they face in agriculture, the kind of problems artisans are faced with, and this should be converted into researchable problems, and the R&D organizations must carry out research to provide solutions for these problems. Then public engagement also today is increasing because we have issues like food security. The population of India is more than 1 billion, and food security must be provided for all the people. Food security means food in adequate quantity, quality should be available for everybody throughout the year. Energy security, we also have this problem of increasing. We depend on fossil fuels to generate electricity. That must change. We must change over to green energy or like solar energy. Water is going to be a serious problem. All cities are faced with water supply problems. People don't get adequate quantity of water per capita in all the cities. So these are the important questions that our science and technology should address. And of course, healthcare is an important issue now. Healthcare is increasingly becoming privatized. Healthcare providers are basically big corporate hospitals. The access, how do we access this kind of healthcare services at an affordable cost is a question. Climate change is also another important issue today. Adaptation and mitigation strategies in agriculture, public health and so on. We have to see how we can adapt to this climate change. So that's why we must look at science and technology as socially embedded forces. Social shaping of science and technology. Society must shape science and technology, and in turn science and technology will shape society. Who should shape this? It is the different stakeholders with their interests and meanings, and the science and technology must be shaped in a democratic manner so that all the stakeholders participate in shaping the technology and trying to improve technologies. National system of innovation, which means creation of innovation in any sector and in any country depends on its national system of innovation, the institutions in the country involved in creation, adoption, and diffusion of a new technology. So these are the national system of innovation consists of institutions, meaning they are organizations involved in creation, adoption, diffusion of new technology. They must be interconnected. And one of the important things that the NSI talks about is learning, that organizations must be willing to learn from each other and also willing to learn from the stakeholders and the people at large. So can India create a context-specific participatory innovation system is a question that we should raise, and I am sure the public who are trying to really engage with science should raise this kind of questions, right. Alternate ways of conceptualizing problems, alternate ways of theorizing and drawing lessons for application. Example, rice cultivation with less water. The system of rice intensification is an innovation that was introduced in our country recently, which this method of cultivating rice requires less water. And also we are using biocontrol agents, plant-based and fungi-based control agents for controlling diseases among the diseases that attack the crops. So biocontrol agents, they are plant-based and fungi-based, and sometimes it's based on fungi that live in soil. Okay. So it is in this context we talk of a post-normal science where facts are uncertain, values in dispute, stakes are high, and decisions they have to be taken urgently. In the sense, we have to combine various elements, various kinds of issues, and then we have to take a decision given the fact that there are a lot of uncertainties, there are disputes in the values, and people have high stakes in what's going to happen about technology, what kind of technologies we are going to have. Now, I think these are assuming significance today. In this context, all stakeholders must participate and then take a decision in a democratic manner. Public engagement in the present context. So the public should demand accountability of scientific organizations. They demand safety of technologies for humans and environment, participation in the innovation process as the stakeholders have stakes in the outcome of the process. I would like to mention one example here, that the recent decision on imposing moratorium on BT brinjal was taken through a participatory process. The Minister for Environment and Forests at that time had public hearings in 6 major cities in the country, and there were a lot of farmers who participated, the industry people participated, and NGOs, civil society organizations also participated. This the outcome of this meeting was the outcome of the meeting led to the imposition of moratorium, and this is an instance of democratizing science. This is an instance of where decisions on science, scientific issues which are going to affect people are taken in a democratic manner. Thank you very much. अभी भी Okay. So in this lecture, we are going to look at the relationship between science and democracy.
Good, sir. Good. Mic लगा दी, sir.
Oh, sorry. Okay. In this lecture, we are going to look at the relationship between science and democracy, and we will see what do we mean by democracy, what do we mean by science, what is the kind of democracy that prevails in the internal world of science, and what happens when science starts interacting with wider society. We will see exactly these processes of interaction between the two. See, science and democracy, if you look at the literature on this relation between science and democracy, and we will see that there has always been a tension between science and democracy historically, because the scientists would look at the kind of issues differently, and citizens at large in a democratic society, they look at things perhaps with a different frame of look at things with a different frame of reference, and that is the kind of tension that goes on between science and democracy. See, we are used to this description of science. It was provided by the philosophers that science is the world of facts and democracy is the world of values. See, the positivist account of science argues that science is rational, value-free and universal, atemporal and invariant system of knowledge, and there is no place for values in science, in the sense that basically scientific knowledge is rational and it is universal. Wherever you go, the same kind of knowledge prevails, and it is also across time it is going to be valid, and across context it is going to be valid. So, that is what, whereas science is in that sense it is universalistic in nature, whereas values can differ across societies over time in societies. So, that is why people say there is no place for values in science. The logical positivists argue that we cannot deduce what ought to be from a description of what is. According to them, science gives a description of the world, and science provides explanations about how the different phenomena are related, but this description, from this description we cannot deduce or we cannot derive what ought to be the situation. The term what ought to be means what is desirable or undesirable. That is, by describing the natural phenomena and by describing various kinds of events in nature and so on, we cannot, scientists say we cannot deduce from this kind of description as what is the desirable state of affairs, right, in the world. So, this is the tension, because the positivists did not admit that values have a place in science. This, of course, has been challenged by many philosophers later on, and the positivists who say that values and facts are dichotomous, they are distinct, they are not going to interact. This is challenged by a lot of people who said that if somebody says that his action is value free, that means he is not able to admit, he is not admitting his own values. That is, values are built into whatever actions we undertake, including scientific action. In the sense, the first kind of value that guides our scientific activities is we attach value to the pursuit of knowledge. We say that pursuing knowledge has its own value, for its own sake we pursue, it is a value. So, if that is the case, how can we not say that values are not part of science? At every stage in science, values guide the actions of scientists. For example, when you define standard research problems, scientific standards. So, these are questions, these are issues which are based on some values. What do we mean by a standard? So, what does one mean by a kind of a relevant kind of research problem? These are issues which are guided by values. So, we cannot say that values don't have no place in science. So, coming to democracy, democracy as a system of governance or a system of arrangement of governing the country, governing the people. It allows people to participate in decision making process in a country. However, the levels of participation and forms of participation varies across countries. See, the level of participation can be very low in some countries, in other countries much more intense, much more deeper, in the sense that one of the important ways in which we participate in democracy is by exercising our franchise, exercising our voting rights. We elect our representatives who go to the legislatures and take some decisions on behalf of us, on behalf of the society, and these decisions are supposed to be doing good to the society. They are going to sort of contribute to the welfare of the society. So, this is one level. We vote and say, believe that our representatives are going to take care of our problems. There could be other levels of participation where individuals are called upon to debate on issues, to react to certain policies, and also give their view on policies and perhaps change the policies and also influence policy making process. So, this happens at various levels, and the forms of participation also varies. It can be in some cases there is a direct democracy in some European countries. On an issue they can always go to people directly and ask for the opinion, and that is another form of democratic participation in decision making process. I think this is what we mean by democracy, and democracy is a value in the sense that it is desirable to have a democracy which allows us to participate in decision making process, which also allows us to give our dissent with certain kinds of decisions. You do not have to agree with every decision that is taken. That democracy gives you that kind of opportunity to give your dissent. That is the that is why democracy is a highly valued kind of a way of doing things. And how do these two things interact? See, for example, for a long time scientists believed that science, within science there is democracy. Science is democratic institution. See, for example, Karl Popper says the context of discovery and the context of justification are different according to him. The context of discovery may be a private affair, but the context of justification is a public affair, as the claims have to be justified by testing them and presenting the claims to the peers. Now, what it means is, see, we don't want to bother about how Newton got the idea of gravity while he was sitting under a tree when apple fell on him. Similarly, we don't really bother about Kekulé when he found the structure of the benzene ring as a snake, as a kind of snake eating its own tail. Then it led to the hexagonal structure of benzene. So, we are not really bothered where they got these ideas while they are walking, while they are dreaming, while they are sitting, but how do they justify these claims? What is the method they use to say that this is what this is what they found and this can be scientifically tested. So, that testing is a public activity. That is how, if somebody makes a claim, it is tested. If it proves to be wrong, then that claim will not be admitted to the body of scientific knowledge. So, this is always at this level there is democracy. People can, the peer group can say what you are saying is nonsense, and they may not admit the claims to the body of knowledge. So, it is in this sense it is democratic kind of an institution. Robert Merton also talks about democracy in science. We will discuss that in a few minutes. Thomas Kuhn, who really contributed to understanding of history of science, who said the empiricist rationalist theories of knowledge are not sufficient to explain history of science, sufficient to explain science. He says science is autonomous and it gets insulated from wider society once the science acquires a paradigm. However, social and cultural factors influence theory choice apart from logic and evidence. What Kuhn is trying to say is that science grows by revolutionary shifts in paradigms. It is not a linear kind of a growth as others positivists would argue. He said science grows by revolutionary shifts in the theories, and for example, geocentric theory or shift from geocentric theory of universe to heliocentric theory of universe is that kind of paradigm shift. That is, the geocentric theory is a paradigm and heliocentric theory is a paradigm. They are very, very different ways of looking at the world. They not only look at the world differently, but they construct different worlds, but they see different worlds actually. So that is that's what Kuhn said. But however, Kuhn says that while a paradigm is being is emerging, how do people get attracted to the new paradigm, new theory? He says at this point there are social cultural factors which influence theory choice. He says that, for example, Kepler, who was a sun worshipper, for him placing sun in the center of the universe appealed to him, because his God, the sun God, is in the center of the universe. That's how he started working on this issue of planetary motions, and he found that he also traced the trajectory of this planets in terms of orbits, their orbits. So basically, so there are this kind of considerations apart from religious consideration. The issues like some people accept a new theory because it is elegant. Some people accept new theory because it's simple. So elegance and simplicity cannot be defined objectively. They are all subjective kind of considerations, or a consideration that is common to a particular group or a community. So in that sense, they are social in nature. So apart from logic and evidence, at certain points in time in history of science, whenever paradigm shifts take place, these considerations also influence people to subscribe to a particular paradigm. Robert Merton, he argues that scientific claims are evaluated on the basis of logic and evidence, and this evaluation is a public evaluation. It's a democratic affair. He argues that practitioners of science have to internalize the ethos of science, universalism, communism, disinterestedness, and organized skepticism. He also subscribed to the view that there is democracy in science. When things are presented, they are tested in public. And he said the ethos of science guide the activities of scientists in the institution of science, and the goal of that goal of the institution of science is to extend certified knowledge, which are certified by these technical criteria like logic and evidence. Universalism, all scientific claims are evaluated on the basis of logic and evidence, irrespective of the class, caste, gender, and race and nationality of the claimant. That if somebody proposes a theory, a new theory, that is evaluated on the basis of logic and evidence. It is not evaluated because that person, it is not accepted because that person is an American, European, or somebody from African country or India, right. So these are irrelevant. If a woman proposes a theory, it is tested, that theory is tested, and if it really conforms to the standards of the test, this is admitted to the body of knowledge. Or if a hypothesis is formulated by a women scientist, is placed for testing, if it tested and if it supports the data support the hypothesis, it is admitted to the body of knowledge. So it is in this sense, there is no distinction, there is no discrimination in science everybody can make scientific claims, and what matters is whether the scientific claims withstand the tests, or whether they can be whether they conform to the standards of rationality and some kind of evidence, right? Post-Kuhnian approaches indicate that scientific knowledge is socially caused. It means that there is an interface with society. The divide between the internal world of science and the external world of politics, external world, that is politics, policy making, economy and culture, is not rigid but a semi-permeable membrane. In the sense, when science, today's understanding is science is not isolated or insulated, it interacts with society and various fronts. For example, in earlier lectures we said today science has become industrialized. There is an industrial science, there is a military science. It means that the interests of industry and the interests of military are really closely linked to science, or science is closely linked to the interests and values of industry, interests and values of military, right. So, science in this interface encounters social values, justice, equality, democracy, freedom, and also the values like profit, values like efficacy and so on, industrial. Science has to sort of encounter these values of justice, equality, democracy and freedom. So, that is that means when they interact with society, the lay public can ask questions, public can interrogate science, public can say what is it going to do to society, whatever scientific research they are doing, what is it going to do to society, and they also can really suggest some ways of finding solutions. This is what we mean by democracy, that it allows people to speak up, it allows people to articulate their views without any kind of reservation or fear. So, as I said, the character of science has been changing. To say that science is value neutral is no longer tenable, as it is intimately linked to industry and military research, as these are associated with values like profit, nationalism, sovereignty, I just now mentioned. So, these are all highly value loaded concepts. Scientists are called upon to advise governments in democratic countries on various issues relating to policy. That is where they have to sort of give some kind of advice which is not only scientific but also is acceptable to people. That notion of acceptability means that there are several interests that operate, several considerations go into making a particular kind of solution acceptable to policymakers, acceptable to people at large. So, this is where the values enter into the advice. So, scientific advice can never be purely scientific, it should take into account the values that certain values relating to what is desirable solution and what is undesirable solution in a particular context. So, scientists are called upon to interact with policymakers, basically to provide some inputs into policy making, and these inputs of course will be evaluated by the policymakers in terms of the acceptability of these kind of solutions by the public at large, because all choices that we make are based on some political decisions, and these political decisions may be challenged by people. Moreover, as science is supported by public funds and accorded legitimacy by the society expects in return certain inputs, benefits or advice from science for policy making and also dealing with solutions, dealing with problems like health, sanitation and so on, various kind of issues that people are faced with. So, science in its interface with society interacts with interest structures, as I said, industrial science, military science, which are based on values like profit, safety, national interests and so on. So, I think these are all we cannot say today science is an autonomous activity, but when it operates in a societal context, the democratic societies can raise questions about science, can raise questions about the kind of solutions that are provided by science and technology. Sorry, state and science interface. See, for example, every country has a state apparatus, and of course, in a democratic country, the state is a institution which takes decisions regarding maintaining the sovereignty of the country, maintaining the welfare of the people, maintaining internal law and order situation and so on. State is supposed to do all this, and in a democratic country, the government of the day proposes certain policies, certain kind of decisions which have to be sort of approved by the president or whoever is the highest, whoever heads the state, and then they become legislations, laws of the land. Science advice on wide-ranging issues, healthcare, to address disorders and diseases. For example, government tells scientists, look, in our country, TB is a serious problem. So, scientists, you must solve this problem, right? It is the government gives a mandate on behalf of the public to provide a solution to the problem of TB, right, tuberculosis. So, similarly, a government can say, in our country, the incidence of cancer is very high, you must find some solutions. This is where scientists then can use their expertise, their theoretical knowledge, methodological skills, methodological rules or methodological procedures to find a solution to the problems like, for example, I mentioned tuberculosis or cancer. It could be some other kind of problem. For example, scientists and technologists may be asked by the government on behalf of the people to solve the problem of let us say problem of energy, right. So, how do people address this? Then the scientists and technologists would put their minds together, use their skills to arrive at a solution. So, the government also requires advice on education. For example, content of education. What kind of education must be imparted to young children, and what should be the scientific content? If it is kind of science curriculum, the government would take advice of the scientists as to what kind of content must be there in the curriculum. So, on various occasions, scientists are asked to give some kind of advice to government and also participate in decision making process. Then public policy in the areas of energy, as I said, quality of water, climate change, and these are issues which concern the society at large, which are going to have implications for the society, and the government asks the scientists to find some kind of solutions for these problems. See, in the context of climate change, scientists have been saying that the climate change is real and it is going to affect our agriculture, it is going to affect our health, and then the government says, what kind of a solution can you give to see that the impact or consequences of climate change do not affect our agriculture. So, what kind of mitigation strategies scientists can suggest, and these mitigation strategies, this kind of issues obviously have to involve people also. So, whatever solution that scientists suggest have to be acceptable to people at large, and then only it becomes a socially acceptable kind of a solution. Engaging public on scientific matters, for example, negotiating on risk, acceptable level of risk. How do we decide what is acceptable level of risk? I mentioned in one of my earlier lectures that the acceptable level of risk is not arrived at purely based on scientific criteria. The acceptable level of risk involves a kind of trade-off between several values, competing values, sometimes conflicting values. Then you arrive at a kind of arrive at a solution which is acceptable to all parties about what is the level of risk which we can accept, right. One should say that ideally zero risk. Of course, certain cases we cannot eliminate risk totally, but certain the risk should be at a level which does not cause harm to us, does not cause harm to our health and environment. So, I think it is at that level we should accept the risks. So, there is this lay people, lay public, like scientists are supposed to be experts. They know that they have the knowledge about natural phenomena, they have the knowledge about how phenomena are related, and public, the lay public means they do not have this kind of knowledge. They may have some empirical knowledge, but they may not have a theoretical knowledge like as scientists have. So, it is in this context science becomes an ideology or a truth. It says scientists are, we have the truth, you have to accept it. It says I have the truth and you got to accept it. This is one way of putting across telling people that they have got to accept what the scientists say. Lay public's practical or traditional knowledge is seen as unscientific and erroneous by scientists, and we should recognize the lay people's knowledge accumulated over the years. It is the first step in democratization of science. So, scientists cannot afford to ignore the practical knowledge that people have accumulated over the years. The knowledge based on empirical observations cannot be dismissed of easily. Evaluation of each other's knowledge, that is understanding the other. When scientists say that lay public's knowledge is limited or erroneous, the public also can say the scientist's knowledge is scientific knowledge and the solutions provided are not relevant to the context in which they are suggesting these solutions. So, there is this kind of a debate that goes on, this kind of engagement that goes on, and it is when science becomes science allows the public to question science, then it becomes far more then it takes the challenge, it is a challenge to the science, and they should really answer these questions raised by public at large. So, scientists also must say that the scientific knowledge is tentative. It is not that they have arrived at final truth. At that point in time, whatever knowledge they have accumulated is a tentative, maybe it will change after some time, but that should be made very clear to people. Scientists have to admit tentative character of scientific knowledge and present it to the public as such. For example, the crop protection against protecting crops against pests by genetically modified seed such as Bt cotton. Bt cotton seed is supposed to provide resistance to cotton plant against pests which attack bollworm, and this kind of the toxic gene which is present in the cotton plant transferred from Bacillus thuringiensis bacterium. This toxic gene will only work for some time because the pests will adapt themselves to this toxic substance, or by either adapt to this or undergo mutation to overcome the the influence of this toxin on their bodies. So, in that sense, the host and pest co-evolving organisms, and it's a very dynamic kind of interaction that one should understand, and the scientists must tell people that this technology is going to work for 2 years or 3 years, and after that one has to bring in new technologies or new ways of solving the problems. So, the decision making process on imposing moratorium on the commercial release of Bt brinjal is an example of democratization of science. As I said, based on public hearings, based on evidence from multiple sources, the decision to impose moratorium was arrived at. And this really created a situation where science and lay public could interact, scientists and lay public would interact with each other and raise their concerns, their questions, right, and pose questions. Public posed questions to scientists, and they were supposed to answer these questions. And the Minister of Environment and Forests at that time asked scientists to do more tests on Bt brinjal to see what are the consequences of this Bt brinjal for human health and environment and so on. In that sense, there is this beginning of democratization of science in our country, and that is, of course, is quite healthy trend. And in a democracy, decision making process may be very prolonged, protracted, but once the decision is made, I think it is acceptable for all, then the implementation becomes easier. Thank you very much.